Welcome to this session on the line clipping algorithm Liang Barsky. So that is the second algorithm for clipping the line against the window. So in previous session, we have discussed the algorithm, that is Cohen-Sutherland algorithm, and various steps of Cohen-Sutherland algorithm that we have discussed. And in today's session, we are going to discuss Liang Barsky line clipping algorithm. Now, in Cohen-Sutherland, algorithm, now what was the problem? So in case of Cohen-Sutherland algorithm, you have to recursively calculate the intersection points, and then you have to calculate the codes, region codes. So this is nothing but in one step. If you apply the algorithm from step number 1 to last step, it is not that you will get the final answer. In that case, what happens? You are finding the region codes for the line, then you are performing the various steps, then again you are finding the intersection points, then again you are finding region codes for it, and this process continues. So means what? In this algorithm, in Cohen-Sutherland algorithm, you have to perform the steps, whatever 1 to 6 or whatever the steps, again and again. So in one iteration, you are not getting the final answer. So to avoid or to remove this disadvantage, we have another algorithm, that is nothing but Liang Barsky algorithm. This algorithm, if you apply the step 1 to whatever steps, you will get the final answer. Means you will get the clip part of the line. So this is the number clip part. So in case of Liang Barsky, you will get that part in one step. Means whenever you will apply the algorithm, you will get final answer. So that is nothing but the difference between Cohen-Sutherland and Liang Barsky. So Liang Barsky algorithm, it is used to remove the disadvantages of Cohen-Sutherland, and it improves the performance. Now we'll start with the Liang Barsky algorithm. So before going directly into the number of steps, we'll derive some formula so that you can understand how the Liang Barsky algorithm comes into picture. Now suppose let x1 y1 and x2 y2 and x2 y2 are the endpoints of line, Then for any point x comma y, you can write the equation of this line as x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1. So you can write the equation and it is equal to u. So there are various types of line equation, like y is equal to mx plus c. So this is one equation. If suppose xy is the any value on the line and x1 y1 and x2 y2 are endpoints of the line, then the equation can be written as x minus x1 divided by x2 minus x1 is equal to y minus y1 upon y2 minus y1. It is equal to u. Now you can simplify x minus x1. Okay, x minus x1 is equal to, it is nothing but x2 minus x1 is equal to, so I will remove it. So is equal to u, and y minus y1 divided by y2 minus y1 is equal to u. So that it is nothing but x minus x1 is equal to u into x2 minus x1, correct? And y minus y1 is equal to u into y2 minus y1. So this is about equation number 2. Now we know that this can be written as, means x2 minus x1. This is difference between x, so we can write delta x, and This y2 minus y1, we can write it as delta y. So put that into equation so that x minus x1 is equal to u into delta x, and y minus y1 is equal to u into delta x. Again, we will simplify for the x and y. So x is equal to what? x1 plus u delta x, and y is equal to y1 plus u delta y. It is y, u delta y, equation number 3. Now we got the equation x is equal to x plus u delta x and y is equal to y1 plus u delta y. Now see, now we know that what we know that the window, clipping window is rectangular in shape, rectangular in shape, correct? In shape. Now in case of, and this rectangular window is rectangular in shape, and what are the coordinates of window? xw minimum comma yw minimum and xw max comma yw max. Okay, yw max. So this is like a window, xw minimum, this is the coordinate xw minimum, yw minimum, and those are the coordinates xw max comma yw max. Now suppose any point x comma y, suppose this is a point x comma y is inside. If suppose this x comma y is inside, then how we can calculate the point is inside? By having the inequality. So what is the inequality it must perform? Suppose let x comma y is the point, inside the window, then it must satisfy the inequalities. What are the inequalities it must satisfy? xw minimum less than or equal to x less than equal to xw max, and second inequality is yw minimum less than equal to y less than equal to yw max. So those two inequalities must be satisfied by the point, then and then only we can say that this point is inside the window. Now after having this, what we will do, so this inequalities can be expressed, or this is can be divided into 4 inequalities. And how it is done? So you can arrange those inequalities, those four inequalities means this is first, this is second, this is third, and this is fourth. The four inequalities. You can do it in terms of UPK is less than equal to QK, where K is equal to 1, 2, 3, 4. 1, 2, 3, 4. So you are arranging those inequalities in terms of U, P of K less than equal to Q of K, where K is 1, 2, 3, 4. 1 is for left, 2 is for right, 3 is for bottom, and 4 is for top. So that 1, 2, 3, 4. 1 is related to left side of the window, 2 is related to right side of the window, 3 is related to bottom side, 4 is related to top side. So U, P of K less than Q of K. Now put K is equal to 1. So this is the xw minimum less than equal to x, this particular inequality related to left side. So that for K is equal to 1, what you can write, x is greater than equal to xw minimum, correct? So same thing. Now what is the value of x? We have x is equal to x1 plus u delta x. So we'll write x1 plus u delta x greater than equal to xw minimum. Now you have to arrange that inequality in terms of u p of k. This is the u p of k must be less than equal to q of k, means u of this quantity must be taken towards this side and this quantity must be here. Then and then only this will become u delta x less than equal to. So this is nothing but taken toward that side. So it will be minus of this one. Then x1, this will come minus xw minimum. Now So you have to compare this with this one. It is compared compare with it is k is equal to 1 means u p of k p1 less than equal to q1. So what is the p1 value? P1 is minus delta x. And what is the q1 value? Q1 is x1 minus xw minimum. So we have calculated p1 q1 for the boundary 1, that is nothing but for left. Similarly, you can write for second. So for k is equal to 2, k is equal to 2, x is less than or equal to xw max. Correct? This is the inequality. Now put the value of x, x1 plus u delta x less than equal to xw max. Now arrange like this, u delta x less than equal to this x1 will be taken here. So xw max minus x1. Now compare with whenever k is equal to 2, it is u p2 less than equal to q2, correct? U p2 less than equal to q2. Now compare with this. So p2 is equal to what? Delta x. And what is the q2? Q2 is equal to xw max minus x1. So this is nothing but equation. Next, suppose it is equation number 5. This is equation number 6. So those quantities you must remember. Those quantities you must remember. Now put k is equal to 3. When k is equal to 3, it is for bottom boundary. So it will become y. Okay, y is greater than equal to yw minimum. Yw minimum. So what is the value of y? This y is from here. It is y1 plus u delta y. So put that y1 plus u delta y less greater than equal to yw minimum. Arrange in terms of u p1, your u p of k less than equal to q of k. So it is u p of k, so that it can be taken toward that side. Hence it is minus of u delta y less than equal to, this will be here, so y1 minus yw minimum, right? Yw minimum. Now compare with the u p3 q3, so that p3 is equal to minus delta y and q3 is equal to y1 minus yw minimum. So this is nothing but equation number 7. Similarly, find out for k is equal to 4. K is equal to 4. So that yw max, or sorry, so that it is nothing but y is less than or equal to yw max. Put the y value, y1 plus u delta y less than equal to yw max. Then arrange in terms of up of k, so it is u delta y less than equal to yw max minus y1. Now compare with this, so that p4 is equal to delta y and q4 is equal to yw max minus y1. So it is equation number 8. Equation number 8. So we have solved, we have found out the p1, p2, p3, p4. And now what is the use of this p1, p2, p3, p4? That is explained in the algorithm. First of all, see, we have started deriving the Liang Barsky equations, few equations from this line with the endpoints x1, y1 and x2, y2. Suppose x comma y is any point on the line, then equation of line will be written as x minus x1 divided by x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to u. Then we have compared it and you have written the values in terms of x and y. So that is nothing but in terms of x and y, x1 plus u delta x. So this is one equation we got, and y is equal to y1 plus u delta y. Then window is considered rectangular, so that any point x comma y is inside the window if and only if it satisfies the inequalities. So those are inequalities: xw minimum less than x less than equal to xw max, and yw minimum less than y less than equal to yw max. Now those inequalities means 4 inequalities, 1, 2, 3 and 4, those are arranged in terms of u p of k less than equal to q of k, where k is equal to 1, 2, 3, 4. 1, 2, 3, 4. By put k is equal to 1, find out P1 and Q1, then put k is equal to 2, find out P2 and Q2, then put k is equal to 3, find out P3 and Q3, find out k is equal to 4 and calculate P4 and Q4. Now we'll move towards the algorithm, actual algorithm. Now in Liang-Barsky algorithm, step number 1 is you have to accept the line endpoints a, x1, y1, b, x2, y2 and window coordinates xw minimum, yw minimum, xw max, yw max is the input. So this is the first step in general. So you have to accept, first of all, you have to accept the inputs. So which are the inputs? You have line endpoints x1, y1, x2, y2 are the line endpoints, and window coordinates xw minimum, yw minimum, xw max, yw max as an input. Now after taking input, find out P of k and Q of k for k is equal to 1, 2, 3, 4. So how it is to be calculated? It is calculated based on whatever formula we have derived. So the formulas P1 is equal to minus delta x, P2 is delta x, P3 is minus delta y, P4 is minus delta y, means positive delta y. Q1 is x1 minus xw minimum, Q2 is xw max minus x1, Q3 is y1 minus yw minimum, Q4 is yw max minus y1. So that is derived by us. So y minus yw minimum. After calculating those values, now what you have to do? You will have the various conditions based on that. If suppose p values are 0, if suppose p1 is 0, then p2 will be also 0. So it shows that the line is parallel, because where x values are same, if delta y and this minus delta y is 0, then it shows that the line is parallel with the y coordinate same, means you can easily identify the parallel lines. Now see here, what are the conditions? If suppose p of k is equal to 0, then line is parallel to kth boundary, correct? See here how it can be. Suppose this is a line, then it has x common, so that the x minus x will be 0. So p of 1 suppose 0 and p of 2 is equal to also 0. So this line is parallel to the line, this left boundary and right boundary. So it shows that if p of k is 0, then line is parallel to the kth boundary. Parallel is not sufficient, whether it is inside or outside, that we have to understand or calculate. Then compare q of k. If q of k less than 0, then line is outside the boundary. You have to discard the line and stop. In case of parallel line, if q of k less than 0, then line is outside. You have to discard the line and you have to stop. If not, if q of k is greater than 0, then line is inside the parallel boundary and calculate the intersection points. Suppose q of k comes to greater than equal to 0, then how to find the intersection points? This intersection point and this intersection point, because x coordinate is same. What is the y coordinate? This is yw minimum and this is nothing but yw max. So that values are x comma yw max and x comma yw minimum. If suppose line is like this, then you will get y coordinate as well as you can calculate xw minimum, and this is xw max. If suppose p of k is not equal to 0, this is for parallel lines, those conditions for parallel lines. If suppose p of k not equal to 0, then you have to go to step number 4. Now what you have to do in step number 4? You have to calculate r of k. R of k is the ratio of q of k upon p of k. R of k is the ratio of q of k upon p of k. So this is nothing but equal to, you have to put k is equal to 1. So it will be r1 is equal to q of k upon p, q1 upon p1. Then r2 is equal to q2 upon p2. R3 is equal to q3 upon p3. And r4 is equal to q4 upon p4. So you have to calculate all those r by putting the value of k 1, 2, 3, 4. Now after calculating r value, determine u1 for p of k less than 0 by selecting relative r of k as u1 is equal to r of k comma 0. Now how this is, or what is this? As we know, p values are, one is minus delta x and one is delta x. So out of two values, one will be negative and one will be positive, right? So that in case of you finding u1, you have to consider p of k minus values. So at least two values will be minus. Related r values you have to put into the set, so that if suppose p1 and p3 are minus, then you can take this as r1 comma r3 comma 0, and out of that you have to calculate the maximum value. And in case of finding u2, consider p of k greater than 0, means positive values. So if suppose p1 and p3 are negative, it means that p2 and p4 are positive, right? It is not always correct. I'm taking for example as a p1 and p3 is less than 0 and it is greater than 0. It may be reversed because the values may change. So in that case, if suppose p2 and p4 are greater than 0, then you have to take into that set related r values, that is r2 comma r4 comma 1, and find out the minimum value. Correct? From this you have to find out maximum value, and from this you have to calculate minimum value. After finding the minimum and maximum value, go for checking the if u1 is greater than u2. u1 is minimum maximum value of r of k, means p of k less than 0 related values, and u2 is minimum value. You have to compare whether u1 is greater than u2. Then if this condition satisfied, then line is totally outside, you have to discard and stop. In case of inclined line, those steps we are performing for the inclined lines. Hence, if u1 is greater than equal to greater than u2, at that time line is totally outside, you have to discard and stop. Now if this condition is not satisfied, then move to step number 7, where you will have u1 less than u2. Then calculate the endpoints of the clip line. How you can calculate the endpoints? By putting that values u1 and u2 into this, x dash is equal to x1 plus u1 delta x, y dash is equal to y1 plus u1 delta y, x double dash is equal to x1 plus u2 delta x, and y double dash is equal to y1 plus u2 delta y. So directly you will get the endpoints where the window is clipping the line, and then you can display the line segment, that is from I dash is x dash y dash, and I double dash x double dash y double dash. So you have to display this. So those are nothing but the steps of Liang-Barsky algorithm. And remember, in case of Liang-Barsky algorithm, in one continuous, means if you apply step number 1 to 8, you will definitely get the clip line. You will get definitely the clip line. It is not the case with the Cohen-Sutherland algorithm, where you have to recursively calculate the intersections as well as the means region codes. But in case of Liang-Barsky, it is not the case. Once you apply step 1 to 8, you will definitely get the clipping candidate or clip part of the line. So this is algorithm. You have to remember this algorithm, how this p1 p2 calculated. If you remember this, and this is very easy. Once we are going to solve the example on it. Once we solve the example, you will definitely understand that this is very easy algorithm. Now we'll move towards the next part, that is nothing but how to solve the problem on this Liang-Barsky algorithm. Now see the example. Apply the Liang-Barsky algorithm to the line with the coordinates 30, 60 and 60, 25 against the window. XW minimum, YW minimum is 10, 10, and XW max, YW max is equal to 50, 50. Now, whatever algorithm or whatever problem, you have to start with the step 1, 2, 3, 4, 5 like this. So if you start with the steps and if you apply the steps properly, then you will get the answer. Now we will start solving this particular problem. Now what is the step number 1? Step number 1 is you have to accept the inputs. So what are the inputs? You can write it in inputs here. X1 is equal to 30, y1 is equal to y1 is equal to 60, x2 is equal to 60, and y2 is equal to 25. y2 is equal to 25. Then xw minimum is equal to 10, yw minimum is equal to 10, xw max is equal to 50, and yw max is equal to 50. So step number 1 is you have to accept the inputs. We have accepted the inputs. Now what is the second step? Second step is calculation of p values, means p1, p2, p3, p4, q1, q2, q3, q4. Now calculate the values. Now what is the p1? Minus delta x. So it is minus of x2 minus x1. So answer is minus of x2 is 60 minus x1 is 30. So answer is equal to minus 30. Then next is p4, p2 is equal to delta x. It is nothing but 30. p3 is equal to minus delta y. So minus of y2 minus y1 is equal to minus of y2. y2 is 25 minus y1 is 60. So answer is minus of 35, and minus minus this is plus, so plus 35. And then p4 is equal to delta y, so it is equal to minus 35. So we got the answer for p1, p2, p3, p4. Now calculate for q1. What is q1? Q1 is equal to this is q1 is equal to x1 minus xw minimum. So x1 minus xw minimum. What is x1? x1 is 30 minus xw minimum is 10. Answer is 20. Then q2 is equal to xw max minus x1. xw max is 50 minus x1 is 30. So answer is 20. Then q3, y1 minus yw minimum. y1 is 60 minus yw minimum 10. So it is answer is 50. And q4, yw max minus y1. So y max is 50 minus y1 is 60. So answer is minus 10. So all those values we got. So we got all those values, p values and q values. Now whenever you are comparing p values and q values, the p values no value is 0, means there is no line. This line is not parallel to any boundary. So you can write it as here p of k is not equal to 0 means line is not parallel, is not parallel. So it is not parallel to any boundary. Okay. Then we must move to step number 4. So what is the step number 4? If it is not parallel, then you have to find R values. So R1 is Q1 upon P1. So what is the Q1? Q1 is 20, P1 is minus 30. So 20 divided by minus 30. So it is minus 2 by 3. Now here p value is less than 0, correct? P1 is less than 0. You must write it because in the later part we have to take this consideration. Then find out R2, that is nothing but Q2 upon P2. What is Q2 value? Q2 is X1 is XW max minus X1. Okay. This Q2 upon P2. Q2 is 20 divided by P2. P2 is 30. So is equal to 2 by 3, where P value P2 is greater than 0. Then go for R3. Q3 upon P3. Q3 value is 50 divided by 35. 50 divided by 35. So 10 divided by 7, where P3 is greater than 0, correct? And then R4. So that is equal to Q4 upon P4. Q4 is minus 10 divided by minus 35. So it is nothing but 2 by 7. 2 by 7 and positive. Now, but P4 value is less than 0. Now see, if P1 is less than 0, P2 is greater than 0, P3 is greater than 0, P4 is less than 0. Why we want that? Because we have to calculate U1 and U2. Now we are moving towards step number 5 where we are calculating U1. So U1 is nothing but a set of values where the P is less than 0, correct? Less than 0. Which are the values related to P less than 0? R1. So that is nothing but minus 2 by 3, comma. This 2 by 7, 2 by 7. And then 0. You have to calculate maximum value. So what is the maximum value of this one? This is 2 by 7. So answer is 2 by 7. U1 is equal to 2 by 7. So that is nothing but maximum value. Now go for calculation of U2. U2 is nothing but the values of R related to P greater than 0. So which are the values related to greater than P? R2 and R3. So 2 by 3, 10 by 7. 2 by 3, 10 by 7 and comma 1. You have to find minimum value. So what is the minimum value you are getting? So minimum value is 2 by 3, correct? 2 by 3. So answer is 2 by 3. U2 is equal to 2 by 3. Now what is the U1? U1 we got 2 by 7. 2 by 7. Now go to step number 6. So what is the step number 6? Step number 6 is you have to compare whether U1 is greater than less than U2. If U1 is less than U2. See, U1 is 2 by 7. Whether it is U2 is 2 by 3. Check whether it is greater than or less than. U1 is greater. No, it is not the case. Means U1 is not greater than U2. Correct? U1 is not greater than U2. Hence, line is clipping candidate. Hence, line is clipping candidate. Clipping candidate. If you are unable to identify whether 2 by 7 is this one, then you can convert into fraction part and then you can compare it. 2 divided by 7 is equal to what? 0.208. So it is 0.2857. And what is 2 by 3? It is 2 divided by 3, 0.66. Is it greater? No. So that this particular condition is not satisfied. Now, as this condition is not satisfied, means line is clipping candidate. Now you can move towards step number 7. Go to step number 7. What is the step number 7? Directly calculate x dash y dash. X dash y dash by putting the values. What is the x dash? Is equal to x1 plus u1 delta x. And what is the y dash? So that put x1. What is the x1 value? X1 value is 30 plus u1 value is 2 by 7 into delta x. What is the delta x? It is 30. So you can calculate the values. Then y dash is equal to y1 plus u1 delta y. Y1 value is equal to 60 plus u1 is 2 by 7 into delta y. The difference between y is minus 35. So 7 minus 2 means it is 10, means it is equal to 50. So it is equal to 30 plus 60 by 7. So we'll calculate it later. Now x double dash is equal to x1 plus u2 delta x. X1 is 30 plus u2 is 2 by 3 into delta x is 30. 10, 20, 50. So answer is 50. Then y double dash is equal to y1 plus u2 delta y. Y1 is equal to 60 plus u2 is 2 by 3 minus of 35. Okay, so it is equal to 60 minus 70 by 3. So we'll calculate it. 60 divided by 7, 8.57 plus 30. So answer is 38. This answer is 38.57. 38.557. This is 50. This is 50. And last it is 70 divided by 3. So answer is 36.66. 36.66. So we got the answers where x dash is equal to 38.57, y dash is equal to 50, x double dash is equal to 50, and y double dash is equal to 36.66. 36.66. So that is nothing but answer, final answer. So you can display that line. You can display this line. How you can display the line? So this is a 10 comma 10 and this is 50 comma 50. Okay, and the line is 30 60 somewhere here. It is 30 60, and second point is 60 25. 60 25 somewhere here. 60 25. Now after clipping we are getting those 2 points, and those 2 points are calculated by this algorithm, and those points are, first is 38 57 50. So it is 38.56 by 50, and another is so it is 38. So this value is 38.56 comma 50, and this point is another point that we have calculated. It is 50 36.66. So it is equal to 50 comma 36.66. So this is nothing but a part of line which is clipped by Liang Barsky, and you have found that in one step you will get the final answer. Means it is not recursive calculation. It is in the, if you apply algorithm from step 1 to last step, you will definitely get the clipped part of line. So I think you have understood the algorithm. It is very easy algorithm. You have to remember the few steps, and then you can solve any problem from this Liang Barsky algorithm. So we have started this algorithm from derivation, and we have calculated the equations. Then we have calculated P1, Q1, P2, Q2, P3, Q3, P4, Q4. Then it is algorithm, step 1, step 2, step 3, step 4, like this, and we have solved the problem based on it. And if you apply the algorithm from step 1 to last, you will definitely get the answer. So this is all about Liang Barsky algorithm. In the next session, we will continue with the another algorithm.